Hello everyone, welcome back to Spectrum classes. Today in this video I am going to discuss about the pH value and the Sorensen scale. So here I am having the solution of lemon, and in this solution you can see the reading, it is 2. Now I am going to wash this electrode, and now I am putting it in the pH 7 buffer, and here you can see the reading pH 7. Now I again wash it, and now I am going to dip it into the basic solution, and the basic solution which I am going to use here is the detergent solution, which is basic in nature. Here you can see the reading. So why this determination of pH value is important? So the determination of this pH value is very important because it play a vital role in controlling and regulation of chemical as well as biological processes. Therefore, it is very important to determine the pH value of a given. Now, the next question comes, what is called pH value of a solution. So, pH value is defined by the Sorensen's equation, and the equation defines that small p then capital H is abbreviated for this minus log base 10 H plus ion concentration. So within the square bracket I have written this H plus. So this is as a whole known as concentration of H plus ions. Actually the potential of H plus ion concentration. So previously it is written as H plus ion concentration, but later on this concentration term was replaced by activity of H plus ion concentration. So how this activity and H plus ion concentration related to each other? So here I am showing you this AH plus is gamma H plus and concentration of H plus ion concentration. So this activity coefficient is very important. The next point is how this pH value is measured. This is the water molecule, and water molecule dissociated like this, H plus ions and OH minus ions. In some of the text you may find this H2O plus H2O, and this is dissociated like H3O plus OH minus, right? So either you can write down in this manner or you can write down in this manner. So both are correct, right? Now this dissociation is there, and we can write down the dissociation constant. So the dissociation constant is product of concentration of product divided by concentration of reactant. Here you can see, right? Now the next point is, if I suppose that concentration of this H2O is constant, because 1000 grams of H2O contains 55.55 moles of H2O. How you can understand this? Weight of H2O is this, and the weight is this, weight 1000 gram moles. So 1000 gram divided by 18, which is the molecular weight of water, so we get this much. So if we consider that the concentration of H2O is very high, or say constant, so this constant value is multiplied by this K, right? So here I have shown it like this. So K into H2O. This gives us a new constant because K is equilibrium constant, and this H2O concentration is again a constant, as I told you here. So these two gives a new constant, which is also known as ionic product of water, right? So Kw here, and the value of this Kw is 10 raised to the power minus 14. If we consider that the concentration of H plus ion is exactly equal to the OH minus ions, then on putting the value of OH minus here, the H plus ion, and these two will gives us H plus, and this is 10 raised to the power minus 14, and this is called H plus square. This gives 10 raised to the power minus 14, and this H plus will be equal to 10 raised to the power minus 7. So here I have written it directly, right? If we take the minus log base 10 on both the sides, then we get minus log base 10 of this H plus, minus log base 10 of this OH minus, and minus log base 10 of this 10 raised to the power minus 7. And as I told you earlier that this minus log base 10 is abbreviated as small p. So this is small p and this H, small p and this is OH, and this is log base 10 as you know, and log base 10 on 10. So this gives us 1 and raised to the power minus 7, and here we are having minus. So minus into minus 7 into this gives us 1, right? So power going to be this outside. So this gives us plus 7 here. You can see, right? So this is how the pH or the pOH, if both are equal in concentration, then we get this pH 7. And this pH 7 is termed as neutral pH, right? Since both the ions have their concentration exactly equal and neutralized by each other. So this pH 7 is the neutral pH. Now, if we have very high concentration of H plus ions, or we can say H plus ions is greater than OH minus ions, then in that case we are having, say for an example, 1 mole per liter. So this 1 mole per liter can be defined as 10 raised to the power 0, right? So if I put this value here in this case, here in this equation, then I will get pH is equal to 0. Similarly, if I have very low concentration of H plus ions, so here H plus ion concentration is less than OH minus ion concentration, here you can see, then we are getting this pH value as 14, because here we are having minus 14 and on putting the value in this equation. So this is called alkaline, or we can say basic in nature. So here, since the values are extremely high and low, so these are the two cases of extremely acidic as well as extremely basic, and we are going to determine the values of pH by using the pH meter. So here what you have seen here, this is the 11.01. So you can tell me whether it is acidic or basic. So since we are having more than 7, then this is basic in nature, right? So here, this is the Sorensen's scale, which has defined the pH values from 0 to 14 level, right? And at 7, we are having this neutral pH, because H ion concentration is same as that of OH minus ion concentration. And here what you have seen, this is the pH 4, and on the right hand side we are having pH 11. So if you forget to remember that this is acid, which one is acidic, which one is base, so the important trick is there. We started with 1 to 14, right? So initially we are having A alphabet, and after 7 we are having B. So A, B, C, D alphabetical arrangement, and this is the numeric arrangement in their ascending orders. So A stands for acid and B stands for base. So before 7, or in the starting 0 to 7, as you know 7 is the neutral pH. So in the starting 0 to 7 we are having acidic compounds, and after that the pH value if more than 7, then we are having the base, right? So this is acidic in nature and this is basic in nature. This is also known as Sorensen's scale.